In this session, we'll be using data at a variety of scales to identify the at-risk academic programs, courses, and students. And we'll be using the research portal of the Autoscholar Advisor system to do that. So just logging in here and then switching on anonymization to protect the identity of the students. And we are first going to look at the whole academic institution and understand in terms of the 3- and 4-year programs the time taken to graduate. So if we look at the 3-year programs, then this graph is showing us that the larger fraction of students take extra time to complete. So the minimum time students are shown here, and then minimum time plus 1 year, that's a higher fraction than the minimum time students. And of course that changes year on year, but it seems to be a persistent trend. Let's now look at the 4-year academic programs. And you can see the picture is quite different. So in this case, the minimum time students are actually in the majority, and we still have a significant number of students completing in extra time. So that's an overall view of the performance across the whole university. Let's now look at the profile of students that are entering this academic program. For example, we can look at the marital status, the religion, the matric aggregate, the quintile, gender, race, all the typical biographical types of variables. So let's look at marital status. And we can see here that there are many more single people than married people or divorced and widowed people. And the matric averages are shown, so we can get a quick sense for each type of variable. We can understand the nature of the students and the metrics involved, and so that's our profile of students across the institution. So that's one view of it. A more useful view is to try to correlate those biographical variables with the performance data. So here we are showing, for example, mean matric points plotted against the graduation rate and the fraction of students that complete in minimum time. And we can see here that there is some kind of positive correlation between matric points and your graduation rate. And you can change this variable, so your matric aggregate is shown there, and we can again estimate some kind of positive correlation. We can also look at gender. And here it is known that males are struggling in comparison with females, so gender is playing a role currently. And of course, race and quintile, those are other variables. And of course, it can be rather difficult to estimate a correlation or to say something is a good indicator. And instead of trying to do it graphically, we have the Pearson R coefficient, which shows us the level of correlation between any two variables. So if a Pearson R value is closer to 1, it indicates a strong positive correlation. If it's closer to -1, it's an inverse relationship. If it's closer to 0, then that implies no relationship. And so from this table, we can start to understand some of the relationships between our performance type variables and our biographical type variables. From looking at this table, it's interesting that the quintile has a strong inverse relationship, while the matric aggregate shows a good correlation. So according to this, students from economically disadvantaged backgrounds, but who still achieved good results in school, can outperform their peers. So much for the biographical information. Let's now think about estimating the performance across our academic programs for the whole institution. So in this view, we get a list of the worst performing academic programs across the whole university. So for example, it's showing us that in this academic program that had 101 students coming in, only 15 of those students completed in minimum time, 30 students completed in minimum time plus 1, and 55 students never graduated. And this is a very large dropout and exclusion rate from this academic program. So we would like to, number one, identify such academic programs, and number two, we would like to unpack what's going on inside these academic programs. So to do that, we go over here to So we'd like a view of the coursework in that academic program. So we've inserted the academic program here, and we click Analyze. And so the system has determined for us a list of so-called gatekeeper courses. So these are courses that occur early on in the academic program and where there are multiple attempts required to pass this course. And so we can see here, for example, it takes 1.54 attempts before this course is passed. And so we have a list here of all such courses. So these courses again occur early on, and they serve as a prerequisite to many other courses in that academic program. So for example here, this course is a prerequisite to several third-year courses, and then those third-year courses are prerequisites to other fourth-year courses. So having a low pass rate here, and here you can see it takes 1.82 attempts before this course can be passed. That's data on average. And so this is a strong gatekeeper in this academic program. It's really slowing down the progression across this academic program. And we can understand its impact if we look here under impacted courses, and it's showing us the courses which are only started later than they could be. So we know that this course belongs in this academic year, but most students are not passing in that academic year. They are not even attempting this course in that academic year. They are attempting it only later on. So these are so-called impacted courses. So we have the gatekeeper courses as the source of the issue in this academic program. And now we would like to understand the issues behind these courses. So let's go ahead and view what's happening in this specific course. And please be reminded that we had turned on anonymization, so the first name and last name and student number are all hashed here. If we look at the performance in this course, we can see quite a lot of inconsistency among the test results. So 40%, 50%, 63%, these are not typical statistics for assessments in a course. And I didn't mention that that is how we estimate at-risk performance. So we are looking at the assessments taken in the course. So of course we want to know which students are underperforming early on. We cannot wait till the end of the course to start advising a student. So during the semester, we want to estimate whether students are underperforming. And in fact, in this case, the whole course is underperforming at such low average marks. And anyway, let's think about whether these students are really poorly prepared. So the fact that the mean mark in all these assessments is so low, it's an indication that there are other issues at play, and it's not necessarily the student preparedness and the student metrics. Now you can go ahead and copy out these student numbers, and you can insert them into the student profiling section. You'll find that the average marks for these students are fairly strong. So these are students that did fairly well in their schooling, and so student preparedness, at least from the matric aggregates, is not a good indicator. So that's another way to investigate the claims that the student preparedness is an issue in this course. So that's where we would start to look at more general issues in the course and the way it's being delivered. But for now, let's say that this was a normal course, that it wasn't such a gatekeeper course, and that our statistics were fairly normal. Then we've identified students at risk here. And so we can, of course, get a quick view of how these students, these specific students, we can look at their biographics and understand a bit about their background. And all that helps us to advise them better. So in terms of advising students, we go over to some of the other components in the AutoScholar. So for example, in the Student Central component, the student could be advised to try troubleshooting their progression. So they can look at different types of advising. So if they're not understanding concepts, or if they can't solve problems, then there are actions that they can take, for instance, forming study groups or engaging with counselors and so on. So The students themselves can be encouraged to undertake certain actions. The lecturers can also reach out to the students. So the system auto-generates emails for the lecturers to address to students. And so it populates the email with specific data about the student. I need your consent on a few. And this helps when generating an email to show the student that you are specifically concerned about that student. That makes a big difference in terms of whether a student will pay attention to that advice. There are other components like casework counseling, so you can schedule appointments with the students, so the system can pick up the types of issues that have been identified for the students, and then the counselor can direct the student to the correct kind of support. And in the casework counselor, we maintain records of what types of advising have been given to students and the strategy being adopted in progressing that student. So overall, we find that a multi-scale approach to data analysis is needed. From the institution scale, we must be able to understand any issues that are cropping up. Then we must be able to zoom into the program scale and understand the programs that are not performing well. Then we must be able to zoom inside of the academic program and be able to understand which coursework is exhibiting some at-risk characteristics. And then we must be able to zoom into the individual students and understand how their progression has been affected over time. So the applied advising must play its role then in improving the graduation rates in the light of this multi-scale view of analysis.